All right. Did you have a good weekend? Yeah? Can't believe it's actually raining. I was surprised to see so many people here. So any questions on homework? I asked you to look at what, like 11 through 20 something or 15 through 20 something. Any questions on those? 1.4? Okay. You said 23? 23? Okay, let me get this out of here. All right, so number 23, limit x is going to 16. And then we've got 4 minus root x over 16x minus x squared. Okay. So what, did you have anything specific on this one? Or did I do this one on video or no? Did you check? I'm sorry?
I don't think so. I'm sorry, I thought you were asking where did you...
Oh, I'm sorry. I thought you were asking me to do that one. Okay. So don't need to do this then? Were there any specific ones you wanted me to cover? Yes. Is this not 23?
Oh, sorry, 22.
22. Okay. I thought I heard, did you say 22?
Yes.
You did. I thought I heard someone say 22. Okay, because that one I probably did on video, right? So for 22, limit u goes to 2. Square root of 4u plus 1 minus 3 over u minus 2. All right, so what is the first thing you always do when you're trying to evaluate a limit? Just plug in, right? That's called direct substitution, right? We're going to just try and see what happens if we replace all our u's with 2. And we're hoping to get something that's not bad, right? But it's going to be bad. So let's replace 2 with u, or u with 2. 4 times 2 is 8, plus 1 is 9. The square root of 9 would be 3. And 3 minus 3 on top would give us 0. So we have 0 on top. Right now, is that enough right now for us to say that this is bad? Having a 0 on top? No. If we have a 0 on the bottom as well, then it's bad. What if we got the number 4 on the bottom? What would happen? Our answer would be 0. Because we get 0 over 4, that's 0. We just can't get 0 over 0. So of course, u goes to 2, you get 2 minus 2, you get 0 on the bottom as well. Right, this is bad. And whenever we see this, this means we need to do some algebra, right? Or some sort of trick. When I say trick, I mean kind of algebra anyway. Like, you know, it's just something. Mechanically, we need to do something to make this work. All right, so did you try something, or what did you try?
I multiplied the bottom and top by square root 4u plus 1 plus 3, and same for the bottom.
Okay, so you came in with the conjugate on the top and bottom. And that is kind of the rule of thumb I said, I think last class, that if you see square roots, start thinking conjugate. So we're going to multiply by 1, but the one we're going to multiply by is the numerator's conjugate. So all we're doing is rewriting the numerator, replacing that minus sign with a plus, and then we're going to expand this out, and we're going to hope to see things become nice. And what am I going to do on the bottom? Am I going to expand the bottom out, multiply this out? No. I said, remember, our goal is to try and get there to be no 0 on the bottom, right? What's causing the 0 on the bottom? The u minus 2, right? If I replace this with 2, I get 0 here. So I want this to cancel. That's why I'm not going to multiply this through. All right. So I move on, proceed through this. When I multiply here to here, let's see, this equals limit u approaches 2. So when I go here to here, the square roots go away completely, right? A root times itself, the root cancels, so you just get 4u plus 1. And then do I need to worry about the middle terms? Do I really need to do those or no? No, right? Because it's a conjugate, we know that when we do this times this and this times this, when we do that multiplication there, those two things will cancel each other out. Guaranteed every time. So I really only have to concern myself with the negative 3 times the positive 3, right? And that's going to be minus 9, right? Negative 9. And then all of this is over u minus 2. And then I still have the square root of 4u plus 1 plus 3 in parentheses. And what does that numerator turn into? I can simplify that. That's 4u minus 8, right? Okay, so now, again, what we're hoping for is something to cancel. Do y'all see it? What do I do to get canceling? Go ahead. Take out 4? Yeah, whoever. Take out a 4, right? Take out a 4 on top. So that becomes 4 times u minus 2 on top. You see it? And do you see the factors that cancel now? So this u minus 2 will cancel with the u minus 2 there. Questions? I'm not done, but any questions up to this point? Am I addressing your question? Okay. So equals limit u approaches 2. Okay, up top, what do we still have? 4, right? That 4 right there is still there. So I have a 4 on top, and on the bottom, the only thing left is this thing right here. I don't necessarily need it in parentheses anymore because it's the only thing down there. 4u plus 1 plus 3. Okay, notice I still have the limit, right? Limit, 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 limit. It's not until this step that I'm going to let u go to 2 that I'm actually going to stop writing the limit. And I should not get 0 over 0 anymore. So equals, okay, 4 on top. On the bottom, let's plug 2 in right there, right? So you just get 8, and then plus 1 is 9, square root of 9 is 3. 3 plus 3 is 6. So you get 4 over 6, and then that reduces to be 2/3. Okay. We good? All right, I wanted to start class with another limit to work on, and then we're going to move on to the next idea in this section. We're supposed to start, according to our calendar, we are supposed to start today on 1.6, and 1.5, I should say. It's hard to see this. See, today is Tuesday, 24th. We're supposed to start 1.5. We're still in 1.4 right now. All right, so we're going to take some time in 1.4, probably half the class, and then I think I may jump to 1.6 and we'll go back to 1.5. I think that's what I'm going to do. Let's see how this goes here. All right, so I'm going to give you a problem. This is kind of like, this problem is one of those ones where I really like it because it has a lot of things going on. Students don't particularly care for it, but it's good to see it, all right? To see this problem done. All right, here we go. So let's do the limit. Let's go x approaches 5. Let's do 1 over the square root of 2x plus 6 minus 1/4 over 5 minus x. All right, first step, replace x with 5, right? Let x become 5. Let's see what happens. So 2 times 5 is 10, right? 10 plus 6 is 16. The square root of 16 is 4. So you get 1/4 here, right? Minus 1/4, 0. So we get 0 on top. On the bottom, 5 minus 5, 0 as well, right? So this is bad. Got to do some algebra, some sort of trick, something, right? It's bad. So algebra, trick, something, right? Okay, does anyone recall what I told you should try and do in this scenario? Let's see. So conjugate, right? You're thinking conjugate because you see a square root in there, right? So that's natural to see it, good. Now, but there's something else going on. You have a complex fraction, right? You have a fraction, but in the numerator you have two fractions. So what did I say to do when you have a complex fraction? Get a common denominator. So the question becomes, should you do the common denominator first, or should you do the conjugate first? And it turns out that you can do it either way, but I always do common denominator first. So I'm gonna first try and put these two together into one fraction. And then I'll see where I am at that point, and then maybe I'll come in with a conjugate afterward, all right? So when I'm focusing all of my attention right now on just this, and I'm looking at the denominators, and I need a common denominator between these two. So what I'm going to do is, let me write it again right here. If you have any questions, just stop me, okay? Raise your hand, shout, start crying, whatever it is you need to do to let me know you need me to address something, all right? Okay, so there it is. Here comes my common denominator. So I need a 4, don't I? So I'm going to need a 4 over here. So I'm going to multiply the top and bottom by 4. And then on this one, I need that entire expression, that square root thing, I need that over there as well. So I'm going to multiply that on top and bottom. So in essence, what I'm doing is multiplying each fraction here. The fraction on the left and the fraction on the right. The stuff in red is just the number 1, right? So I'm just multiplying by 1s to make it look different so that I can combine them together. All right, let's do it. So now this becomes limit x approaches 5. So what I'm going to do here now is multiply 4 times 1, and that's just 4. And put that here. And then because this is a minus sign, I'm going to put minus, and I'm going to multiply these two together. 1 times that root is just that root. And then all of that is over the common denominator, right? Because they both have the same denominator. What I'm doing is I'm putting them together. So my common denominator will be the 4 times the square root. 4 times the square root of 2x plus 6. Now, don't forget, all of that is still sitting on top of the 5 minus x. Questions on that piece? Common denominator? I want to pass back your quizzes. Does anyone have any objections to me passing them around and letting you grab yours out of here? Other people might see your grade. Any objections? Sure? Okay, so I'll pass those out. I'll start those out over here. And then, yeah, and then the sign in, I'll start that over here. Any questions on what I've done there up to this point? What do you think I'm going to do next? Anyone have any ideas? What's that? Oh, you mean like take the bottom and then flip it up? You could do that, yes. Let me put that here. Before we get to that, do you think we still have a problem here? If we let x go to 5, do you think we still have a problem? Yeah, because we haven't canceled anything, right? Nothing is canceled out yet. Our goal is to get something to cancel. So you could start doing like a flipping, but really, I'm kind of at that stage where we started with maybe a conjugate, right? Like, do y'all see up top here, 4 minus this, 4 minus that right there? I can multiply the top and bottom by the conjugate and just hope for the best. All right? So the flipping that was being suggested, I think, was to rewrite this as like 5 minus x over 1. Is that right? And then you could flip it up. You could do that, but nothing's going to cancel yet because we need the conjugate. So I'm going to come in with the conjugate now. So when I multiply by the conjugate, because I have a fraction here, watch what I do here. I'm going to go 4 plus that root. And then over here, 4 plus that root again. Okay, so I'm multiplying by 1 again, but the 1 I'm using is the conjugate of this top piece. Why am I doing the conjugate, right? Like, why? Because I've been told that the conjugate usually helps with this, so I'm trying it, right? I'm going to see if this actually gets me anywhere. So this is going to be multiplied here. All right. Let's go ahead and multiply this out. And again, I'm just going to multiply here to here. I'm not going to worry about the middle terms, so I'm only going to have to do the last terms multiplied together. Those are the only two things I'm going to concern myself with because the middle will cancel every time. I'm going to silence my phone. I forgot to do that. Hold on. Okay. All right, so this is what we got. Limit, x approaches 5. All right, so when I multiply 4 times 4, I'm going to get 16. And now, on this next multiplication, I'm going to do a negative times a positive, right? A negative times a positive, which should give me a negative. And now this is where students mess up. When I do this root times this root, right? When I do them, the root goes away, right? So I should just get 2x plus 6, right? But there's a negative is sitting in front of it. So when I write it, I have to write it like this. 2x plus 6 in parentheses because that negative will distribute to each of those terms. If you don't put the negative, things aren't going to work, all right? I mean, if you don't put the parentheses, things will not work out. You won't get any cancellation. Okay, all of that is on top of now on the bottom here, this whole thing right here, I am not going to multiply those together. I'm just going to leave them the way they are. So it's going to look terrible. It's going to be 4 square root of 2x plus 6, and then parenthesis 4 plus square root of 2x plus 6. Put the parenthesis in the wrong place there, sorry. And then all of that is on top of my 5 minus x. What do we got? Anyone see what I'm going to do next? What are we trying to get to cancel? What do we want to go away? This is the thing that causes the division by 0, right? We want that to go away. Do y'all see where what it's going to cancel with? Anybody else need to sign in? This table? Okay. Ow. Okay, so up top, y'all see we can distribute this negative through. If we do that, what do we get up there? 16 minus 2x minus 6, right? And then what would that become if I just simplify that? Are y'all okay? Or is everyone like in mourning from the Cowboys or something? What's going on here?
Subtract the 6 from the 16.
Okay, so take 16, subtract that 6, and that would give you 10, right? So now this becomes 10 minus 2x. One more step. What?
Simplify it.
How? What do I do with that 10 minus 2x? What can I do?
Minus 2.
Not divide, we'll factor 2 out. Factor 2. Pull a 2 out front. So if I pull a 2 out front, so pull a 2, I'm running out of room here. 2, and then what am I left with inside? 5 minus x. You see that? All right, so let me write what we really have here. This is limit x approaches 5. On the top, I pulled a 2 out. I have 5 minus x. Below that, I have the 4 square root of 2x plus 6, and then in parentheses, 4 plus the square root of 2x plus 6, that really ugly denominator. And then below all of that, I have 5 minus x. And now the 5 minus x's are going to cancel. But you need to be clear on why they're going to cancel. Be absolutely clear with your algebra why they go away. You could just, if you want, if you're happy with it and say, yes, I understand what's happening here, you just cancel them. But to really understand what's going on, this is where you can look at this as a fraction. And then you have a fraction divided by a fraction, which is the same as multiplication of the reciprocal, right? That's what division really is. So what I'm really doing is I'm taking this fraction and I'm multiplying it by the reciprocal of this, like that. And then I don't have to worry about that anymore. So I've like flipped it. And now do you see the 5 minus x's cancel? And this is where I said, you know, as long as we, little asterisks over here, as long as x isn't 5, I can do that, right? And remember, I'm taking a limit, so I'm letting x get close to 5, so this is valid. All right, so I think I'm ready to actually take the limit now. I'm gonna let x go to 5 into this expression, but remember, these are gone, right? That's gone, that's gone. So up top, I have a 2. On the bottom, let's see, what happens when we plugged in 5 here? 10 plus 6, 16. Square root of 16 is 4. So this will be 4 times 4. 4 times 4, parenthesis, 4 plus what? 4 again. 4 plus 4. So this is going to be 2 over, let's see, 4 times 4 is 16. But then 4 plus 4 is 8, so 16 times 8. Let's reduce. Let's just reduce one factor of 2 here. Make it a little bit easier for us. So I get 1 over, let's see, what's that? 16 times 4, 64? Right here. Okay, this right here is 4, isn't it? Right? Because it's 2 times 5 is 10, plus 6 is 16, square root of 16 is 4. So that's 4 plus 4, right? 4 plus 4. And then this one was 4 times 4. Good? It's pretty nasty, huh? You get a common denominator first, then you've got a conjugate, then you've got a factor, cancel, plug in, right? Okay, anything else here? All right, so if you did your homework and you followed along in class last time, you understand that when it comes to limits, when we get 0 over 0, we're looking for algebra, we can have all sorts of things, right? You might have to get common denominator, you might have to do conjugate, you might have to do difference of squares, difference of cubes, sum of cubes. There's all these different things that could happen, right? And this is an example where you had 2 things happening in one problem. So, yeah, this is the nature of the beast, okay? We're going to continue now into this section, we're addressing the same idea, but it's going to look like we're kind of doing something different, but it's still the whole thing about we've got a limit, we've got 0 over 0, bad algebra trick. It's still the same basic concept. So I'm going to give you a limit right now. I want us to look at it, and then we'll proceed. So how about this one? Limit x approaches 0 of sine of x over x. Pre-cal. Everyone took pre-cal, right? So first thing I'm going to do is direct substitution. And I feel like a drum roll in the background here. let x go to 0. What is sine of 0? 0. Why? It's cosine 1. So how are you doing that? So how are you doing that? I'm just curious. You memorized them? You memorized it. Okay, so you're either going to have to memorize this, or anyone else? Unit circle? Yeah? So, yes, so the unit circle from pre-cal, right? If we have any angle, theta, and some point, remember this is the unit circle, so I mean the radius of this is 1, then the x and y coordinates are always given by cosine of the angle, sine of the angle. So whatever angle you're at, whatever the x coordinate is cosine of that angle. Whatever the y coordinate is sine of that angle. So if I want to know what sine of 0 is, right, plug in 0. If I want to know what sine of 0 is, I go over to the unit circle. I go to the angle 0, which is right there, right, straight out the x-axis. So I'm really looking for that particular problem. What I'm doing is I'm looking at this point right here. And I'm looking, that's the point, well, you had to go to the right one, right? You don't go up or down. So I'm looking for the y coordinate here. And the y coordinate here is 0, right? So sine of 0 is 0. Cosine of 0 is 1, right? Sine of 0, cosine of 0. All right, I don't know how you learned it in your class, but I expect that everyone has a pretty good grasp, very good grasp, on the unit circle and what the different values of sine and cosine are around that circle. If you don't, you need to go get brushed up on that, come to my office, we can go over it, whatever. All right, so up top, what are we doing? We're getting 0, right? And on the bottom, of course, if you replace x with 0, you get 0, right? 0, 0, this is bad. What do we do? So algebra is some trick, right? But see, what algebra are you going to do here? Are you going to cancel these x's? Can you do that? I mean, that technically, that x is inside that sine function, right? It's inside. It's the argument of the sine function. You can't just get, I mean, what would happen here? This would be what? What would you be left with? It's a sin. See? It's a sin to do that. It's a stupid math joke. All right? All right? But it would, see, you can't cancel these. So what do you do? What else? I mean, what else do you have? I mean, there's nothing that we have, right? There's no sort of difference of squares. There's no conjugate. There's no, let's get a common denominator. You just have a single fraction. There's absolutely nothing we can do, all right? So we're stuck. Well, I'm here to tell you that for now, where's my cursor? There it is. For now, we are going, where did it go? Oh, there it is. Why did it do that? For now, I'm going to give you a formula that will allow you to do this, and we're going to just accept the formula on faith. We're going to take it on faith because I'm telling you, all right? And then later on this semester, I will prove to you why this is true, all right? So there's no algebra we can do. I'm just going to tell you, all right? Can you all be okay with that for now? So this part in yellow, I'm going to pause and come back. This part in yellow here is not in your lecture notes. So at the end of class, I'll put this back up if you want. You can take a picture of it, or you can do it now if you want. I'd prefer you wait till later. But let's look at what this is, what this says, all right? And I'll make it a little bit bigger so we can see it better. All right, so the first piece here, this number 1, says that, let's say you're taking a limit and you're letting x go to something, okay? It actually doesn't matter what x is going to, all right? And up top, what you have is sine of some junk. And when I say junk, I mean it can be anything. Doesn't matter what it is. It's just something, all right? We're just called just this junk that's sitting inside the sine function. Let's say you're taking the limit of sine of some junk over that same junk. So whatever appears here is exactly what appears there, right? So it says it down here. The junk is exactly the same on top and bottom. So let's say you have that happening. Is that what we had in that example? I had limit, x was going to 0. I had sine, I'll put parentheses around that x, sine of x over x, right? That x is like my junk, okay? And do you see I have the same junk down here? These junks match, okay? That limit will be equal to, well, this says that it actually doesn't matter if you had it upside down. Like you could flip this over, right? So if this was flipped and you had the x on top and sine x on the bottom, you would get the same answer. And the answer is 1. Okay, so this limit is 1. I'm telling you that, you're taking it on faith. All right? Now, there are some conditions on this junk. First of all, like I said, the junk on top here, in here, has to match this junk. They have to be exactly the same. And the junk has to be going to 0. That's the big condition. So when you look at this right here, I'm going to put in red, like I said before, this is our junk, right? That's our junk right there? This is our junk. Are they exactly the same? Yes? Are they is this junk going to 0? Yes, x is going to 0, right? So this junk is going to 0, so the answer to this is 1. There's no work to be done. It's boxed, and I'm finished. All right? Yes?
So for the question mark in the formula, it would have to be 0?
No, let me give you another example. That's why I didn't put 0 here, because it actually could be something else. Let's do another one.
Oh, that makes sense. Clicking. Everything's lining up.
All right, let me do another example. We'll get to the number. There's another one after this, number 2, but let's just stick with number 1 for right now. So how about this? Limit. Let's let x go to 3, and let's go sine of x minus 3 over x minus 3. So you look at that and you go, okay. Direct substitution. Let me try. Let's let x go to 3 first. If I plug in 3 here, I get 0, right? Plug in 3 here, I get 0. What's sine of 0? 0, right? So we get the 0 over 0. This is bad. But we have to recognize now that we have the junk and the junk, right? And they match, exactly match. So here's our junk. They match exactly. And do they both go to 0? As x goes to 3, they both go to 0, don't they? So my answer is 1. Is that all right? Again, don't ask me to explain why. If you really want to know why, I can tell you, but you have to come to my office. It's a beautiful proof. It's geometric. It's awesome, but it'll take like 45 minutes to do. So I don't have time in here. Later on in this class, we will have developed a new tool, and I'll be able to show it to you in about 10 seconds. But we just don't have that tool yet. All right, so let's do another one. How about this? Limit, let me see if I can trick you. X goes to 3, sine of x minus 3 over x squared minus 9. So first thing is direct substitution. Let x go to 3. 3 minus 3 is 0.